Today we're going to be talking about GPS, or your global positioning system. Specifically, you're going to have a Garmin GPSMAP 66S. Many of these work very similar. Even people's phones have a lot of these features on it. We're going to be using a handheld device, and I'll show you a couple of things that we can do with this. First off, we're going to look at, this is the unit itself. So in the Academy, we're going to be working with this one or some very similar one, but this is just put out by Garmin. They're a pretty common one that is able to that produces GPS. So the first thing we're going to do is when we open it up, we need to get to the battery. So there's a little latch on the bottom. So this is a little pin that will stand up on its end. You need to twist it 90 degrees. So basically you start there, twist it there, and then pull on it. It will then open up and allow you to install the batteries in the back. So that just popped off right there. It uses 2 AA batteries, so it's pretty straightforward. As just a note, there's a micro card, SD card underneath here that you can put satellite imagery on or record a ridiculous amount of data if you really want to. But that's located behind the batteries if you ever need to get to it. The seal itself is weather resistant, so it's got a little seal on it, so make sure that you don't lose that. When you power this unit on, it's got basically this circle with a dash in it, so you're just going to push and hold that until it powers on. This can be located in a different place depending upon which GPS unit you're using, but with ours, it's right up there next to the antenna. You know you're cooking with gas whenever you get that little the Garmin symbol there, or wherever your device is now started up, so you can let go of the button on the top and let it power up and go to the main screen. Once you're at the main screen, it can be a little daunting because you got all these buttons and all of these choices here, but we're really just going to use just a few of them. So the easiest thing you need to know is you're going to push the menu button. That's how you're going to get there. Menu, page, and then the arrows. You've got enter, you've got quit. Those are mainly the things you're going to be working with here. Relatively easy. These other ones basically zoom in and out of the map. You can mark, you can drop points if you're wandering around, that sort of thing, or you could locate stuff that's stored in your data, all that sort of fun thing. But we're basically going to look at just a handful of these things, how you set this critter up, and then how you can get it working. So the first thing we're going to do is we're going to look at, you go to the menu. When you go to the menu, you'll notice that you've got a lot of options here. One of those is setup. So if you click on setup, so you highlight setup, hit enter, it's going to bring you over here and you're going to see system. When you get to system, this is where we're going to move around and look at our data. Okay, so you go to your system, and then when you scroll down from system, first thing we're going to find, and I'm going to ignore all these things up there, they're all groovy, you can learn them eventually, is we're going to look at position format. So one of the big rookie mistakes is not having your GPS set up in a way that's easy to use. So I highly recommend that you use decimal degrees. So basically this is going to be 35 degrees north. Instead of doing degrees minutes a second, it's going to be 35 point something something something. And this is just easier to write down because typically you don't change your first number very much. In fact, just the last couple digits are the ones that are changing in your area. So you kind of do a shorthand, write out the full thing first, and then you can just do shorthand after that. The other thing, which I won't get into too much here, but I want to make sure that you have the right datum and spheroid set. So you want to make sure that's WGS84. So this is going to be directly related to your projection. Should also be WGS84. That's World Geodetic Survey. And the reason for this, just in a really quick nutshell, if you guys know GPS, is you can do this in a projection. You can do this in any projection that your software wants to work in. I recommend doing this because it's just a Cartesian grid. Your latitude and longitude are going to be very easily translated. You can put those points where they need to be in your software, and then we can then put it in a projection we need. I just find you eliminate any possible error by just getting your latitude and longitude based on Cartesian grid, based on very, very straightforward system there. So when you're done, you just click quit, and that will slowly back you back out of the menu once you've got those things set. So if you go back to your setup here, so if you go to setup and you can, this screen anyway, you can start scrolling down, and then you're going to find satellite. Usually it's down toward the bottom, and you just do that by pushing the down arrow, the over arrow, till you get there. When you highlight satellite, you're going to hit enter. So see, we've only gone to 2 things on this, and that's all you're going to have to worry about when you're playing around with the GPS so far. When you get there, this is going to give you the celestial sphere. So what you're looking at here is you've got north, south, east, and west sort of thing. So this is designed to be held straight up and down, just like your Kestrel or your weather device. And so you're looking straight at the screen, straight in front of your face, and it's up and down, so you don't lay it flat. The direction that you're facing would be the direction that this little red dot is. So I'm facing almost north here in this particular instance. And then what's going to happen is it's going to calculate for all these satellites that should be up above you. You're looking at the celestial sphere, or the celestial dome, I should say. So around the outside is the horizon line around you. This dot is directly over the top of your head, and then imagine a dome over the top. So what you want is you want satellites down along around this circle here. So if they're along the horizon, they don't do you a lot of good. If they're directly over the top of you, they don't do a lot of good. So you want to make sure that these satellites are actually getting a decent signal. You can actually scroll this button here, and you can see that there's even more satellites that are being picked up. So it only shows you, I think, 11 or 12 at a time, and you can scroll through those depending on how many are up above you. The more satellites you have with strong connections, the better off you are. And so this is showing you how good the connections are. Like this one hasn't been found, should be up there, but we don't know where it is. That's where it's located. This one's down near the horizon, so it's not reading it. In full disclosure, I'm inside. I'm also blocking my exact location, so you'll get full digits out there if you use this little critter here. Here's where your margin of error is, so always record this. This is plus or minus 10 feet, so this point within 10 feet in any direction is where that point is located. Now you get margin of error in GPS for any number of reasons. One of the important things, if you're ever using GPS, always make sure that you're keeping track of your margin of error, because that can be quite a big difference when you're trying to map this. So here's just an example of how the celestial sphere works. So here's me stepping outside. It's a little bit of a glare on it, so forgive me there. But we can actually see we picked up that one satellite that we had before. Almost all the bars are full here, so we're getting a really good reading. The black lines are the ones that we're getting only a pseudo reading, but we've got lots of satellites. We especially have the satellites around that nice little white ring there. That's going to make us very happy, so we're going to get a decent rating. We're still at plus or minus 10. You see, we can see that our numbers are rolling in pretty good. So that's how we're going to use our GPS. So you just simply write down your latitude and longitude. Another shorthand, instead of writing down west, you can write down -89. But you always do north latitude and longitude when you're writing it down. Annoyingly, when you put it into the computer, you put it in longitude and latitude, because we do easting and northing, if you really want the official terms for it. But we'll get into that when we talk about mapping, and that won't be for quite a while. So really quick, common mistakes that you can make with the GPS is that if you're standing under trees or next to buildings, you can actually get the sound bouncing off of it, so you don't get a really good signal from each one of the satellites, or you don't have enough satellites connected. Another issue, not waiting long enough. It doesn't take a whole lot of time, and I usually like to give it 60 seconds, 5 minutes, when I first start using it. It's going to take the numbers really quick once it's locked in, but let it be out in the open area, away from everything. Let it sit there for a good minute or 5, just so that it's kind of trained. And then when you walk it around, you're going to get your data very quickly. The other problem is you're writing down your latitude and longitude, but your margin of error is greatly over, I've seen it as high as, 50 feet. If we're using meters, we want it to be within 3 meters. If we can, plus or minus is kind of a rule of thumb, because that's really where the lower cost GPS gives you a bigger margin of error. Other common errors is that people don't write down their margin of error right. They don't use the right projection. I always recommend getting it to WGS84. It's just the easiest to transfer the data. Whenever you have those numbers, you put it into your GIS. Or your Google Maps or your Google Earth or whatever, you can get those data real easy. If you're using a projection, there's some nuance to it that you don't get when you do WGS84. So just always make sure that your projection and your datum's right. Another problem is not writing down the full number. So always add the cardinal direction, north, south, east, west, whenever you're talking about which direction, because this is telling you how far north or south of the equator you are and how far east or west from the prime meridian that you are. And that runs through Greenwich, United Kingdom. Another problem that I see a lot of times is confusing what points are what, because you write down all these numbers, and if you don't keep track of what data are what, then it can become a mess and you don't know what you're dealing with. So try to keep track of that. How it works, well, I'm going to be really brief about how it works, but basically the satellite sends out with a pseudo-random signal at a known time. So it's basically got an atomic clock in it, and it starts playing a song. I like to describe it as a song. It starts playing a song at a given time. Now it's going to take time for that song to reach the listener, in this particular case, the GPS. The GPS knows what time it is, what day it is, and it knows where the satellites should be based on their orbits. And it goes like, all right, satellite number 24 is sitting up over here. It's playing this song. It was supposed to start it at, 3 nanoseconds past noon. So I'm going to listen for it. Oh, I hear satellite number 24. And I notice that there's a bit of a delay because it takes a while for sound to arrive. Something that happens really far away, you don't hear it till it gets really close. That thunder from lightning hits really close, you hear it immediately. But if you see it way off in the distance, it takes a little while to travel to. That difference in time between when I know the song started or the pseudo-random signal started and then when I heard it, I can calculate a distance for how long it took sound to travel that far. That lets me know that if, say, my satellite is this yellow sphere here, I would be somewhere within a sphere around that object based upon how long the difference is between when it played the song and when I heard the song. So it can calculate those times. If we get multiple satellites, if I get 2 satellites, say the green satellite here, I am so far away from the green satellite and so far away from the yellow satellite. That means if these are 2 spheres, I can be somewhere within a circle that's going to connect at those 2 dots, somewhere out there in the universe. So if there is another satellite, there's a red one, and it adds another sphere, I'm this far away from the red one, this far away from the green one, this far away from the yellow one, there's only one location that I can be, well, technically 2, one on the top and one on the bottom anyway. There's only one location where all of these things connect, so that's where I'm located. As you see, we're trying to use 10, 15, 20 satellites. We're going to start reducing that down quite a bit. Ultimately, the margin of error that you get, that plus or minus 10 feet, has to do with software. It also has to do with how well it's been trained to known locations. But we also get interference to say there's a lot of moisture in the atmosphere, or the ionosphere has a strong charge to it. These can change the speed in which the signals are transmitting. Or that satellite itself could be messed up and it started a little bit late. So we have ways of finding out which satellites are behaving properly. And so higher end GPS tends to use those sorts of things. Your phone, most cell phones now have a GPS in them that are doing the same thing. They've got the data, they know where the satellites are, they're going to calculate it. So if you're using this in a scientific method, try to always record the margin of error along the latitude and longitude so that you can keep track just exactly where you are. All right, so there's my whirlwind tour of the GPS. I know it's really daunting when you first look at it, but just know that you go to settings. This is one a screen that you can go to. There's a system screen. Learn what's on those. Really all you're looking for is the make sure that your map units are in the right format, and then make sure that you're looking at that satellite screen. It'll show you what satellites you're seeing, and then what your position is, and then your margin of error. And that's all you really need. Feel free to play with all of it, but that's what I'm going to help with you here. All right.